Hello and welcome. Oh, I'm making sure we're recording. Yes, recording. Yay. Hello and welcome. This is Mrs. Hossfeld. We are in 8th grade math. I know this is a crazy week. Today is the 17th of February. I had to go look at my date to make sure I had it correct on my computer because it's been just crazy here. And I'm sure it's been crazy where you've been at too. But I thought, well, even though we don't have math class, maybe you'd like to look at a little bit of the volume stuff that we've been talking about and see a little bit about a volume of the sphere, which is what we're talking about today. Our warm-up is what is the volume of this cone? You know, this cone right here on the screen. Let's see if I can use my tools. I'm in neuro, by the way, getting practice for neuro. So if I make some mistakes, I apologize in advance. And so what is the volume of this cone? Think about it. We have a diameter of 6 inches and a height of 9. And we'll see if we can do that in a minute. In the meantime, I thought I would just show you. I went for a little walk in my neighborhood. I live right next to a state park. This is what we saw yesterday when we walked over there. Pretty cool. You'd think we were in Ohio or Colorado, but no, it's right here in Central Texas. We also did a little bit of barbecuing. As you can see, I'm a barbecue master and just was having an awesome time with those steaks. And here are my kids doing math at home. Isn't that great? Even though little guy, he goes to public school. He takes algebra. He's in 8th grade. But he still likes to get help from his brother over here. He's in college. He's actually online in school just like you are, but at the college level. And he's a strong math student. He's actually the reigning state champion for UAL math, 4A, Division 4A. So this guy is always asking him for help, whether he needs it or not. All right, so let's go back to this problem. It says a party hat is shaped like a cone. The dimensions of the party hat are shown in the diagram. Which measurement is closest to the volume of the party hat in cubic inches? Okay, so actually look at this. We don't even have to do the math. We just have to know our formula, right? So we know that. So just tell me, what do you think the formula is? Is it is it volume equals base times height? Look at that little b. Is it the little b? No, that's a little b. We want the big B, right? We want the base, you know? We want that right here. So we want the whole area of this circle. So in order to get that, we have to have the large b, right? That formula looks like something familiar, but is it for a cone? No, this is for a cylinder. We need, a cone has got about a third less. Look, it doesn't have all this stuff like a cylinder would or over here. So it's this formula right here, C, volume equals a third of the base times the height. And if you got that right, you're aces. Okay, if not, it's no problem. We get a formula chart, right? Just so we know how to use it. Okay. All right. A party hat is shaped like a cone. The dimensions of a party hat are shown in the diagram. Which measurement is the closest? We know that. So here it's asking, what does B stand for? Well, I just told you, right? So let's see if you could get it. Is it base? Is it length of the base, area of the base, or perimeter of the base? Is the area of the base of the big base, baby. Capital B. How do I make a capital B with my, there, does that look kind of like a capital B? Backwards, maybe? Okay, capital B, area of the base, the whole entire base. Not just the little, not just a line. You want the whole area of the circle. Okay, cool. All right. So Let's move on to the next question or next thing. A party hat is shaped like a cone. Okay, the dimensions of the party hat are shown in the diagram. Which measurement is the closest to the volume of the party hat in cubic inches? Oh no, they're going to actually make us do the formula. We can handle that though, can't we? We can handle the formula. So get out your calculator. I'm going to have out mine. And by the way, guys, if we move too fast at any point, feel free to stop the tape and, go over and take your time and do what you have to do. Because I don't have anyone here to ask questions, so I probably won't pause as much as I do in a normal class. All right, so the first thing I want to do is I want to put in our formula. And our formula, as we just determined, is volume equals 1/3 the big base times the height. Hey, you guys see that? So I'm going to figure out, what do I know? I know I'm looking for V, right? I'm looking for V. And I know that it equals 1/3 the base, which is pi r squared, right? Pi r squared. So I'm going to put the pi, but as you all know, I don't have the pi on this computer. So I'm going to multiply it times 3.14 times r squared. Well, r, we know the radius is half the diameter of the circle, right? Half of the diameter of the circle. And being we know that it's half the diameter of the circle and the diameter is 6, we know it's got to be 3. It's got to be 3. So we're going to do 3.1 1/3 times 3.134 times 3 squared. Okay, now knowing that, go back, Mrs. Hossfeld. How did I get over here? Where are we? Here. Okay, so for some odd reason, it did not let me put it in again. Just so you know, I'm practicing with Nubro. Did I say that already? Okay, so there's our formula. So let's do the math and figure out what we get. The first thing we do is our exponents, right? Because we know PEMDAS or PEMDAS, you do the exponents first. So 3 squared is 9. So we multiply 9 times 3.14 or pi. If you have pi on your calculator, please go ahead and use that. And we get 28.26. And we multiply that by 1/3. And multiplying by 1/3 is the same as doing what? Excuse me. It's the same as dividing by 3. So just to make my life easier on my calculator, I'm going to divide by 3. And I am going to get 9.4. But I'm missing one step, guys. What am I missing? What did I not put here? Because we didn't have it yet. I didn't put the height, right? Okay, so I'm going to add the height in. And the height, we said, is 9, right? So we're going to add that height. All right, so when we do that, when we multiply this times 9, we get 84.78. So do we have anything really, really close to that on here? 84.82. Yeah. When you're multiplying and dividing, if you use the pi key, or if you multiply by 0.3 divided 1 divided by 3, or if you multiply by 0.33 or 0.434, you're going to get very slightly different angle or degrees. So when we're doing the volume, sometimes it's not an exact number. Sometimes it's just extremely close. Okay, it's called, they're rounding errors. So this is extremely close, and it's fairly safe to say that that's the correct answer. All right, so now our essential question of the day is, how do I solve problems involving volume of a sphere. Sphere, oh my goodness, that's different, right? It's a sphere. You're sitting on one right now. What's it called? The Earth, right? The Earth. Maybe you're standing. You could be laying down in bed. I don't know, but you're on the Earth. You're on the Earth. So that's a round ball. It's different. It's not a cylinder. It's not a cone. So how do we figure out this problem? And today, by the end of this lesson, you should be able to solve problems involving the volume of spheres so that you can use mathematical language to solve for volume. And you'll know you have it right when you can explain to a friend how to solve the volume of a sphere. Okay, so how many cones does it take to fill up a sphere if they have the same radius? Let's watch. Let's watch. And in order for me to do this, I'm going to have to share my screen with you. It'll just take a second.